One thing I really like about SageMaker is, especially with the built-in algorithms that are coming out, there's a really big repository, a GitHub repository, that has like a Jupyter notebook that walks through an example. It has some example data, and it walks through how to train and deploy each of these algorithms. And I was wondering if you could speak to the decision to kind of create this really big repository in addition to documentation.
Right. The idea behind the repository came, we first decided we wanted machine learning, so our mission really is to put machine learning in the hands of every developer, right? So that's our mission. And to do that, we really thought about reorganizing the way we build technology around machine learning. So we built an entire stack that has 3 main layers. At the bottom of the layer, we make machine learning and deep learning frameworks available. Those are the TensorFlow, the MXNet, the PyTorch, Horovod, all these good programming languages of machine learning that deep developers, data scientists, research scientists would be very knowledgeable in, and they'll be able to play around with that naturally. But that's not for everyone, right? So if you know exactly what to do, if you can play with GPUs and recompile GPU libraries, then yes, you'll be very comfortable there. But then at the middle layer, we also built a lot of automation, like I said earlier, for building, training, and deploying machine learning algorithms, and that's really where SageMaker fits in. And at the top layer, there's a bunch of application services for computer vision and all this other stuff. But because we care about, we want to talk about SageMaker for now, I'll focus on that. Now, automating the infrastructure was not the whole job. Like, the job is not done if you just automate the infrastructure, because you still have people that are not particularly very familiar with machine learning algorithms. So what we decided to do is to bring in the most popular, the most common, the most useful machine learning algorithms that exist out there. XGBoost is one of the competitions winning machine learning algorithm nowadays. Some computer vision algorithms, principal component analysis, k-means, k-nearest neighbor, linear regression, logistic regression, multi-class classification. So you're probably familiar with these names if you've played around with machine learning. So what we set out to do as a challenge is to essentially take these algorithms, optimize them for large scale, for large data sets, and then make them available in Amazon SageMaker. The other thing that we decided to do is to go to our internal team at Amazon and say, hey, what are the cool algorithms that you guys are working on at the moment? And so we got some nuggets from there. An algorithm like blazing text, which is an improvement on word2vec. That essentially gets you to, we use that internally at Amazon to build word embeddings, right? To build embeddings of products, of items, of user comments and things like that. And so we got that from that team and then packaged that and put that in SageMaker. So when you embark on a journey of not just making platforms and services, but also algorithms available to people, I think a very natural thing to do is to also put examples around those algorithms to make sure that people can use these algorithms with a lower friction of entry. So then we decided to build a lot of examples around initially these algorithms, but also people got super excited and just started contributing to these examples. So we ended up eventually with more than 30, and it's probably a lot more now, Jupyter notebooks that we open sourced and that are also available within SageMaker. So the idea there was to make sure that if a data scientist and or developer wants to use SageMaker, they can jump on the platform, not just have access to the infrastructure and all the automation, but also have access to essentially an example that can get them through building, training, deploying, hosting, tuning machine learning models end to end. And we wanted to make sure that everything is available there, including some sample data. So that was the entire idea. And it started as a small project and it grew because people started contributing. And we also enable our external customers to contribute to that library, which is available on GitHub. And it's an ecosystem that is growing pretty large around that. And that's one of the things I'm also very proud of.
Yeah, I think it's an amazing resource. And I was thinking, like, with especially the use of Jupyter notebooks, it really ties into what we try to do at Udacity with education, right? It's like a question of how do you make this the most accessible by creating a sort of framing that allows people to really focus on whatever machine learning problem they're trying to solve, whether it's something with data or something with an algorithm, sort of reducing any any extraneous information there, and like allowing them to explore and play around with these, I think is something really powerful.
Yeah, and people learn by doing, right? So if it is possible for you to, after learning about k-means or k-nearest neighbor algorithms, find a way to implement that right away in a matter of, I don't know, 10, 15 minutes by just following instructions, it becomes real. It becomes real. And then you can eventually deploy that in a web service or something like that, and then use the product. So I think the ability to bring that association with an example that guides the learners is very useful. And then, yes, we're seeing a lot of momentum around that capability.
Mm-hmm.